Okay, so today we are reading chapter 10 of Automate the Boring Stuff with Python, and it is organizing file. In the previous chapter, you learned how to create and write to new files in Python. Your program can also organize pre-existing files on the hard drive. Maybe you have had the experience of going through a folder full of dozens, hundreds, or even thousands of files and copying, renaming, moving, or compressing them all by hand, or considering tasks such as these, making copies of all the PDF files and only the PDF files in every folder, in every subfolder of a folder, removing the leading zeros in the file name for every file in a folder of hundreds of file names, compressing the contents of several folders into a zip file. All these boring products and stuff is just begging to be automated in Python. By programming your computer to do these tasks, you can transform it into a quick working file clerk who never makes mistakes. As you begin working with files, you may find it helpful to be able to quickly see what the extension like .text.pdf of a file is. With Mac OS and Linux, your file browser most likely shows the extension automatically. With Windows, the file extension may be hidden by default. To show extensions, you have a different path. On the View tab, you have to do something. The Shuttle module. So the Shuttle module or shell utilities module has functions to let you copy, move, rename and delete files in your Python program. To use the shuttle functions, you will first need to use import shuttle, copying files and folders. The shuttle modules provide function for copying files as well as entire folders. Calling shuttle.copy source and destination will copy the file at the path source to the folder at the path destination. Both source and destination can be strings or path objects. If destination is a file name, it will be used as a new name of the copied file. This function returns a string or path object of the file which is copied. And then we have entering a command line which will demonstrate how shuttle.copy works. First we will import shuttle, and then from pathlib we will import path. P is equal to path.home, shuttle.copy, p spam.txt will be a source, spam.some p some folder will be a destination folder. Same thing we can do x.text file and or to a same path with of same folder slash x.text. So we can create the file there. The first shuttle.copy call copies the file at C and the specific folder. The return value is the path of the newly copied file. Note that since a folder was specified as the destination, the original spam.txt file name is used for the new copied file name. The second shuttle.copy calls also copies the file at the specific location but at the folder what folder is given, but gives the file name as ex2.txt, whatever file name the destination path has been specified. While shuttle.copy will copy a single file, shuttle.copy tree will copy an entire folder and every folder and file contained in it. Calling shuttle.copy tree source and destination will copy the folder at the path source along with all of its file and subfolders to the path destination. The source and destination parameters are both strings. The function returns a string of the path of the copied folder. Enter the following in the interactive shell. We will be again importing shuttle and path from pathlib. We will be calling path.home in a p variable, and then we will be calling the shuttle.copyTree function. We will be giving a spam folder and a spam backup folder. It will copy the content of the spam folder into the spam backup folder. The shuttle.copyTree call creates a new folder named spam backup with the same content as the original spam folder. You have now safely backed up your precious spam. Moving and renaming files and folder. Calling shuttle.move source and destination will move the file or folder at the path source to the path destination and will return a string of the absolute path of the new location. If destination points to a folder, the source file gets moved into destination and keeps its current file name. For example, Enter the following into interactive shell. Import shuttle.move. It will move the file bacon.txt into X folder by giving the file name and the folder name. Assuming a folder name X already exists in C drive where we are moving, we'll move the content to CX. If there had been a bacon.txt file already present in the destination folder, it would have been overwritten. Since it's easy to accidentally overwrite files in this way, you can take some care when using move. The destination path can also specify a file name in the following example and the file will be overwritten. Then we will be moving to both of the previous examples worked under the assumption that there was a folder X in the directory of the destination. But if there is no folder, then the move path will rename the bacon.txt file to a file named X. So basically, if there is no folder, the file name will be X. And finally, the folder that make up the destination must already exist, or else Python will throw an exception. Enter the following into interactive shell. So if the folder is not existing, then the path, if you suppose that you have moved the file with shuttle.move spam.txt C does not exist /x/ham, that means the after C the folder is not existing, which has been called, so Python will throw a file not found error. Permanently deleting files and folder. You can delete a single file or a single empty folder with function in the OS module, whereas to delete a folder and all of its content you have to use the shuttle module. Calling os.unlink path will delete the file at path. Calling os.rmdir path will delete the folder at path. Calling shuttle.remove rmtree path will remove the folder at path, and all the files and folders it contains will also be deleted. Be careful when you are using this function in your programs. It is often a good idea to first run your program with these calls commented out and with print calls added to show the file that would be deleted. Here is a Python program that was intended to delete files that have the .txt file extension but has a typo highlighted in bold that causes it to delete the .rxt files instead. So if you see, it will find the using the glob. If I can read the line, it's importing the OS, then from pathlib we'll import the path. For file name in path.home.glob will find out all the file name which is coming up with the specific expression, and it will unlink the file name. If you had important files ending with .rxt instead of which we have typed for .txt, they would be accidentally permanently deleted. Instead, you should have first run the program like this. So it would have been printing the file name. Now, so what it has done is it ran the print function to call the file names, and it would have got the exact file. Now the os.unlink call is commented, so Python ignores it. Instead, you will print the file name of the file that would have been deleted. Running the version of the program first will show you that you have accidentally told the program to delete some random file instead of a specific version. Save deletes with the sendto module. Since Python's built-in shuttle.remove rmtree basically, the function irreversibly deletes files and folders, it can be dangerous to use. A much better way to delete files and folders is the third-party sendto module. You can install this module by running pip install --user sendto from a terminal window, and you can see Appendix A on more in-depth explanation of how to install the third-party module. Using sendto is much safer than Python's regular delete function because it will send folders and files to your computer's trash or recycle bin instead of permanently deleting them. If a bug in your program deleted something with sendto you didn't intend to delete, you can later restore it from the recycle bin. Walking a directory tree. Say you want to rename every file in some folder and every file in every subfolder of that folder. That is, you want to walk through the directory tree, touching each file as you go. Writing a program to do this gets tricky. Fortunately, Python provides a function that handles this process for you. Here is an example of a os.walk function on the directory tree. import OS for folder names, comma subfolders, comma file names in os.walk, and then there is a bracket in which the path has been given. Print the current folder. For subfolder in subfolder, print subfolder of that particular folder name, and for the file name in file names, fill file inside that folder name. And this is how you can print everything. The os.walk function is a passed single string value, the path of a folder. You can use os.walk in a for loop statement to walk into a directory tree, much like how you can use the range function to walk over a range of numbers. Unlike range, the os.walk function will return three values on each iteration loop through the loop. A string of the current folder's name, a list of strings of the folders in the current folder, a list of strings of the file in the current folder. By current folder, it is meant the folder of the current iteration of the for loop. The current working directory of the program is not changed by os.walk. Just like you can choose the variable name I in the code for I in range 10, you can also choose the variable names of these three values listed earlier. I usually use the names, folder name, subfolder, and file names. So if you run the program, you will be able to see. Since the os.walk returns list of strings from subfolder and file name variable, you can use this list in their own for loops. Replace the print function calls with your own custom code. Or if you do not need or both of them, remove the for loop. Just go through the first iteration. If you see, we have first went to the path to get the folder. And then in that folder we go to the subfolder, and in that subfolder we go to the file inside it. Compressing file with the zip file module. You may be familiar with zip files with the .zip file extension, which can hold compressed content of many other files. Compressing a file reduces its size, which is helpful for transferring it over the internet, and since a zip file can also contain multiple files and subfolders, it's a handy way to package several files into one. This single file, called an archive file, or can then be, say, attached to an email. Your Python programs can create and open or extract zip file using the function in the zip file module. Say you have a zip file named example.zip that has the contents shown in figure. The figure I'll explain it to cat.names.txt, zofi.jpg. You can download this zip file from anywhere. The link given in the book was https://no-com AutomateStuff2. Reading zip files. To read the content of a zip file, first you must create a zip file object. Note the capital letters Z and F. Zip file objects are conceptually similar to the file objects you saw returned by the open function in the previous chapter. They are values through which the program interacts with the zip. To create a zip file object, call the zip file.zipfile function, passing it to a string of the .zip file's extension or file names. Note that zip file is the name of the Python module and zip file is the name of the function. So basically, a small zip in all small letters, zip file is the name of the Python's module, and init caps is the name of the function. For example, if you are importing, you will use import small letter zip file, and for calling the function you will do the init caps where Z and F will be capital. So a program was like this: importing the zip file, os from pathlib import path. We have a variable where we'll be storing the path.home. Then we will have example.zip file where we'll be use equal to zip file.zip file, and then we will be going to the path p/example.zip file. And that in zip file we will call the name list function, the example zip.namelist. It will give us all the contents of the file. Then spam info will have a variable. We will be storing the spam.text, and we will be printing the spam.fileset, and then we will be doing the spam.compressize. So we will be doing the same thing, but then we will be having a ptprint functionality where we will be showing that f compressed file is round spam info.file size / spam info.compress size, comma 2 x is smaller. So basically 2 times smaller. So it is like we will be doing the output of that will be coming as compressed file is spam file dot size divided by spam file dot compress underscore size and comma 2, that is the rounding fraction, so it will be coming as 3.63x smaller. A zip file object has a namelist method that returns a list of strings for all the files and objects contained in a zip file. The strings can be passed to getInfo zip file method to a zip file object. That particular zip file objects have their own attributes such as file size and compressed size in bytes, which hold integers of a original file size and compressed file size, respectively. When a zip file object represents an entire archive file, a zip info objects hold useful information about a single zip file in the archive. The command at calculates how efficiently example.zip file is compressed by dividing the original file size by the compressed size and prints this information. Extracting from zip files. The extractall methods will be used here. So the same thing, example.zip is equal to zip file. So here the example of example zip variable which is containing the zip file which is present in a specified location will call the extractall function, and in that way we will be able to extract all the files. Then creating and adding to zip file. To create your own compressed zip file, you must open the zip file object in write mode by passing the W as the second argument. This is similar to the opening of text file in write mode by passing W to the open function. So when you pass a path to the write method of a zip file object, the Python will compress the file at that path and add it into the zip file. The write method first argument is a string of the file name to add. The second argument is a compression type parameter which tells the computer what algorithm it should use to compress the files. You can always just set the value to zip file.zip file deflated. The deflated compression algorithm which works well on the type of data. Enter the following into interactive shell. We will be importing the zip file, we will be storing the new zip file into a variable, and in the variable we will be writing it, and then compression type will be zip.deflated. So this code will create a new zip file that will be named called new.zip as we have mentioned, and that has the compressed contents of spam.txt. Keep in mind, just as with writing to files, write mode will erase all the existing content of a zip file. If you want to simply add files to the existing zip file, pass A as a second argument instead of W. Summary. Even if you are an unexperienced computer user, you probably handle files manually with the mouse and keyboard. Modern file explorers make it easy to work with a few files, but sometimes you will need to perform a task that would take hours using your computer's file explorer. The OS and Shuttle modules offer functions for copying, moving, renaming, and deleting files. When deleting files, you might want to use the send to trash module to move files to recycle bin or trash rather than permanently deleting them. And when writing program that handles file, it is good idea to comment out the code that does the actual copy, move, rename, delete, and a print call instead, so you can run the program and verify exactly what it will do. Often you will need to perform the operation not only on files in one folder, but also on every folder in that folder and every folder in those folders, and so on. The os.walk function handles this track across the folders for you so that you can concentrate on what program needs to do with the files in them. The zip file module gives you a way of compressing and extracting files in .zip archives through Python. Combined with the file handling functions of OS and Shuttle and zip file makes it easier to package up several files from anywhere on your hard drive. This .zip files are much easier to upload to a website or send as an email attachment than many separate files. Previous chapter of this book has provided a source code for you to copy, but when you write your own programs, they'll probably won't come out perfectly the first time. The next chapter will focus on Python modules that will help you analyze or debug your programs so that you quickly get them correctly.